Hello and welcome back to SEACO Girls OpenFOAM tutorial series. In the last video, we ran our very first OpenFOAM simulation using the study case. In today's video, we'll learn how to create a mesh in OpenFOAM using the blockMesh utility. We'll be working with a hotRoom case. Okay, so yes, so this is the blockMeshDict file. This is the blockMeshDict file, as you can see. Okay. And let's start from the upper side, from the starting. So like up to this portion, this is the common portion, or you can find it any of the in any of the OpenMesh or OpenFOAM dict file. Okay, and it will be common for the OpenFOAM blockMeshDict file. You'll find, okay, only the thing will change is like object. Okay, so if you are making the blockMeshDict, so you have to write a blockMeshDict. If you are going for the control dict, then in the object you have to write the control dict. Okay, and everything will remain same. Okay, dictionary and everything will remain same. Okay, so this is the common part. Nothing to explain much in that thing. Now the thing start from this one. Okay, so this here it is written as the scale. Okay, so what do you mean by scale? Scale means like, okay, like how do you want the your mesh, your mesh, your like how it looks like. Okay, that is the part. Okay, so let me explain. So like, for example, if the value of the scale is equal to 1, all right, so like, for example, if you wanted to make a cube of 1 meter, 1 meter and 1 meter. Okay, so like x is 1 meter, y is 1 meter and z is 1 meter. All right, so if you want your cube, like your cube in the same dimension, okay, so you will keep the value of scaling as 1. all right, now if you wanted to give the original dimension here, but you want for the CFD simulation, you want your room to be smaller. Like, for example, you want your room to be new dimension, you want to be 0.5 meter, y 0.5 meter and z 0.5 meter. Okay, so as I have told you in the previous video, that if you wanted to make any domain, you have to give the vertices. Okay, so like if you are making complex vertices, like for this case we are taking a very small example, but in the case of the smaller in the case of the complex spaces, what happens is like there are many coordinates, so you will not going to change each and every coordinates each and every coordinates. All right, so in that case, scaling comes to help. Okay, so what we want is like, what happens is like, okay, in the CFD simulation, it may happens like the CFD simulation, like you can say that it is heavy or it is lighter. Okay, the CFD simulation is running fast or slow, so that depends on the number of nodes. Okay, number of nodes in the mesh. Okay, number of nodes in the mesh. Okay, so if the mesh is there, if you wanted to make, okay, so like it depends on that part. Okay, yeah, so number of nodes you can decide it by two things. So one thing is that, one thing is this. So if you wanted to, like you are running and it is becoming very heavy, or you are not able to solve that one, like your computer resource is not able to run the simulations completely. Okay, so with the help of the scaling, what you can do, you can small that model. Okay, small that model, you can decrease the length. Okay, so what you can do, you wanted to decrease the length in x, y and z by 0.5. what you can do, you can give the value here as 0.5. okay, so what it will do, it will multiply 0.5 with each and every coordinate. Okay, and so it will become, so for example here it is 10 given, so 10 into 0.5, it will become 5. Okay, and here it is given 0.5, it will multiply by the y also, so 0.5 into 5, so it will become 7.5. No, it will become 2.5. All right. So like this. Okay, so or if you wanted to increase, you have to give the value of the scaling greater than 1. Okay, so in this short, if I'll write down in the short form, if I write down, so if you wanted to decrease the domain size, if you wanted to decrease the domain size, scale will be less than 1. No, increase scale greater than 1, and same scale value will be equal to 1. Okay, so for in this case we wanted to keep the same dimensions. Okay, same dimensions. So like this you can, okay, because it happens, it's like you make some new case and you find out that the case is becoming very big. Now you will again go and change each and every dimensions. Okay, like in any 3D modeling software, there you can make the changes very easily, but making the changes in each and every coordinates is very tedious task, and you may get inaccurate. Some of the coordinates may you may forget to change. Okay, so that is the thing. So to get rid of that thing, this scaling comes to help. Okay, scaling comes to help. All right, so that is the scaling one. Okay, so I'm removing this because I have to write other part, explain other things here, so that's why I'm just removing it. Okay, all right, so let's move on to the vertices part. Okay, so this is our main thing. Okay, the vertices, this is our main thing, the vertices. Okay, so like for example, again we are making an case of a room only, or you can say that is a cuboidal room only, or a cube room. Okay, the like the shape is cube only. So like let's make it like that. Okay, so I'm just making it. Okay, all right. So in OpenFOAM, what happens is like you have to give the coordinates, because you give the dimension with the help of the coordinates. So first you have to specify the points, which is here given as the vertices. Okay, so for example, this is number 0. Okay, so like here you can see 0 1 2 3 4 5 6 7. Okay, so what does that mean? That it is the first coordinate, that is known as the 0, because OpenFOAM works in the C++, and C++ starts with the 0. Okay, so the first is like it numbers at the 0. Okay, so like first is 0, then it's 1, this one is 2, this one is 3, this one is 4, this one is 5, this one is 6, and this one is 7. Okay, so that is the thing. So there are 7 coordinates are here. Okay, there are 7 coordinates are here. So like it is for example 0 comma 0. Now this one is 10 0 0. Okay, this one is 10 5 0, and this one is 0 5 0, this point. So it is 0 1 2 3. All right, then again on the back side, this one is 0 0 10, because on the z axis, because okay, so the 3 1, it is like defining is like this. These you are defining x, y, and z only. So this x, y, and z. So this is x, this is y, and this is z. All right, that is the point. Okay. So yes. So again, this one is 0 comma 10. This one is 10 0 10. This one is 10 5 10, and this one is 0, 5, 10. Okay, that is all the thing here. That is all the things here. Okay, so like this you define your mesh. If you wanted to make, so you define it like this. Okay, for example, if you are making like medium complex structure, like for example like this one, like this, for example like this one. Okay, so the case is like water is flowing and in the flow there is some obstruction is there. This is hollow. Okay, so obstruction is there. So for that, now you have to define it like this. First you have to define this point, then this point, then this point, then this one, then this one, then this one, this one, and this one. Okay, and all the coordinates, all the things you have to give in the coordinate form. Okay, so for this one, okay, what I suggest people is like to define, to comment down the lines. So this is the first line that will be marked by 0, this is the second line that will be marked by 1, 2, 3, 4, 5. So I just usually suggest the people to make the markings. Okay, but if you do not make the marking, OpenFOAM will automatically take it as the first one as 0, second one as 1, third one as 2, like that. Okay, and then it will start using it. Okay, so like it is like giving the naming in the form of the numbers. Okay, so you are giving the first vertices name as 0, second one name as 1, third one name as 2, like that. Okay, like that. All right, so this is the part. Now comes to the blocks. Okay, what is blocks? Blocks is like making the mesh. Okay, so like you have defined, okay, this will be my dimension. Okay, this will be my space. Now blocks will help in making the mesh. Blocks will help in making the mesh. Like how many blocks you want in x direction. So like here it is written as 20. Okay, so I want 20 number of blocks in x direction. So will 1, 2, 3, 4. I have made like only 5, but yeah, I mean you can make it 20 also. In the y direction I want 10 blocks. So in the y direction will increase like 10. Okay, and in the z direction we want 20 blocks. So it is like the number of blocks nx, ny, and nz. Okay, so these are the things with the help of which you can make a mesh finer or coarser. Okay, finer means you have to give a much larger value, coarser means you can give the value less than this. Okay, I'll show you the tutorial also, don't worry about that. Practically also we will do in OpenFOAM, and then I'll show you that how it is increasing or decreasing, don't worry about that. But first it is required to explain the whole blockMeshDict file. Okay, yes. Now comes to the simple grading and 111. Okay, so this one is the complex, little bit of complex thing, so I will explain it in the later on video. All right, that is the part. Now comes to the boundary. So like which face you are defining it what, like giving the name specifically. Okay, so like they are defining as like 1, 5, 1, 5, 4 and 0. So this one is 1, this one is 5, this one is 4. Okay, so this one is 1, 5, 4 and 0, like this. Okay, like this. So this one they have to define as 4. So you can see that the floor has been defined with the help of the naming, numerical naming which has been given to the vertices. Alright, same ceiling also 3762, same the fixed walls and all those things. Okay, so like that you do the naming. Okay, like that you do the naming, like that you make the like type and all those things you give. So that is the defining of the boundary condition, like defining the faces, like which one you are considering as the inlet, which one you are considering as the outlet, which one you are considering as the face. So there you have to define like type. Okay, so here all the boundaries are considered as walls, but yeah, if you wanted to some like something is there and you wanted to make the inlet, so like flow of the water, so this part will be treated as the inlet. So there you have to define type as inlet and choose the naming of the thing, like how to name that one. All right, that is the part. So that is the thing which I wanted to tell you. Okay, so yeah, major part has been completed here in the blockMeshDict file. I will just now let's move on to the directly doing in the OpenFOAM. Okay, basically I would like to show you like how you can make the mesh coarse and fine. Okay, here only. Okay, so that is the thing, and after that we will conclude the video. All right. Okay, so let's move on there. Okay, so let's check back the blockmesh directory here in this one, blockMeshDict. So yes, so here you can see this is our blockMeshDict which I have explained you before also. So here, okay, so the thing which I wanted to tell you about, like how you can make the mesh coarse or fine. Okay, so for making a mesh coarse or fine, you have to make the changes here only in this part. Okay, only in this part. All right, so let's get back, and this is the original one. So what I will do, I'll just run again the blockMesh. Okay, mesh has been made, and type check mesh. Check mesh command will give you all the details here. All right, so here you can find that the points are 4,851. Okay, so these number of points are here. All right, now what I will do, I will just open it in the ParaView also, so that you can figure it out, like by looking it also, like okay, how the mesh is. Okay, and we will then make in the next one we will make the mesh finer by changing the number of blocks in X, Y and Z direction, and from there you can just and by looking there you can also check that okay, the mesh is fine or it is like that. Okay, so yeah, you can see that the mesh is right now like this. Okay, what I want for good results, I want to make this mesh finer. Okay, so just keep this picture in mind. We will just make the mesh finer. Okay, so what I will do, okay, I will just click the screenshot of this. The screenshot of this. Okay, so this is the screenshot which I have took. Okay, so let's move it. Let's close the ParaView. Okay, press ls. I will clear the terminal. Then I will again go to system, and I will again go to blockMeshDict, and here what I will do, I will increase the number of blocks, okay, to make the mesh finer. So what I will do, I will give 50 in the x direction, let's give 20 in the y direction, and let's give 30 in the z direction. Okay, and save it and exit. Then I will go back, and then I will again run blockMesh. Okay, now what I will do, I will just again type check mesh, and here you can see that the number of points has been increased, 33,201. Okay, so let us open this in the ParaView. So paraview.exe phone. Okay, let's open it and press apply here. So what you can do is like just press wireframe, and you can see that the mesh has become finer. Okay, so let me compare. Okay, so let's make a comparison. So this was our previous grading, and this one is, let me make some adjustment. So yeah, you can see the clear difference. Okay, this one, the previous mesh is coarse and this mesh is fine. Okay, so like this you make the mesh finer or coarser. Okay, so yeah, this is all about the blockMesh. Okay, I have given you a simple example. This is the basic thing which everyone should know. Okay, this is the very basic thing, because if you don't know this thing, then you cannot go to the complex one. Okay, So to run the advanced OpenFOAM simulation and with the complex domains, complex symmetries, you cannot work if you don't know the basic things of the blockMeshDict file. Okay, so each and every dict file you must know about the basics. Okay, like okay, what does it mean? What does it mean? All right. So yeah, thank you for watching. That is the thing which I wanted to discuss in this tutorial. Now you know how to generate a mesh in OpenFOAM using blockMesh. Don't forget to like, share and subscribe to SEACO Girl for more OpenFOAM tutorials.